talk about arithmetic sequences, which are one particular type of sequence. Arithmetic sequence is a sequence in which the difference between consecutive terms is constant. That means if you take any two terms that are next to each other and subtract them, you should get the same thing, no matter which two you pick. So you pick any pair of numbers that's next to each other and subtract them, and we should always be getting the same thing. Or another way to say it is that term to term, as we move throughout, we are adding the same thing every time. Okay? The common difference, then, is that thing that we're adding. And we use the letter D to denote difference. So our first type of question asks us to decide whether the sequence is arithmetic or not. I believe the directions in the homework say to decide whether or not it is arithmetic and to explain. So in this question, is this an arithmetic sequence?
Yes.
Yes. Okay, well, our explanation then would be saying, what are we adding? So what are we adding here? 4. And that works all the way through. -3 plus 4 is 1, plus 4 is 5, plus 4 is 9, plus 4 is 13. Okay? So by explanation, it doesn't have to be like a long, well-constructed sentence. We can just say, yes, because there is a common difference. That common difference we're adding is 4. Is this one arithmetic? No. Why not? There's no common difference. And that's enough of an explanation. And since we use the letter D for common difference, we can just say that there is not a D value that works here because we're adding 3, then 5, then 7, then 9. There's a pattern to what we are adding, but it is not the same thing every time. So this does not meet the requirement of being arithmetic. Okay. Go ahead and look at the next two, which ask the same question. Okay, so what about this one? Yes or no? No, this is an example of needing to be careful because as we begin, we could add 4 and then add 4, so we might be tempted at that point to say yes. But if we continue to check, then we add 2, then we add 2, then we add 4, then we add 4. So make sure that it continues to work, not just that it starts working. So this one is no. What about this one? Yes. And what is the common difference?
Mr. Cowell to the high school office, please.
So we have a common difference of 6 on this one. Okay. So adding 6 gets us from term to term all the way through. This formula will give you the rule for an arithmetic sequence every time. So in our previous lesson, we talked about how if we're adding the same thing over and over and over, that rule should have a multiplication in it. And this rule does. It's multiplying that common difference, what we're adding, by some value of n. In terms of notation, a sub 1 means the first term. And D, just like on those first ones we talked about, means the common difference. N and A sub n are your variables. So those should be there in your rule. In your final answer for your rule, those two things should be there. A sub n means some term of the sequence, and n is its place in line. Like it's the 3rd term or the 26th term. But n means its place in line. You do not need to memorize this formula. It will be printed on the test. So this question asks us to write the rule and then to find the 20th term. So we're going to use that formula. A sub n equals, A sub 1 means first term, so that would be 50, plus n minus 1 times D is the common difference. So what are we adding each time here? -6. We always want to, with a difference, think about what we are adding So if our inclination is to say that we're subtracting 6, instead think about adding a negative 6. Okay, the common difference should always be what we are adding to get from term to term. To clean up this rule, we need to distribute that in. It becomes negative 6n plus 6, and combine like terms to get a rule of 56 minus 6n. So the directions ask us to write a rule and then also to find a sub 20, which is the 20th term, and that is found by plugging 20 into the rule. Another way of doing it would be to just continue the pattern on until we get to the 20th term, but there's a lot of possibility for an arithmetic mistake in there, and I mean 20 isn't so bad, but what if I asked you for the 200th term, right? So with a rule, we can just plug in any number we want into the rule for n and find that particular term. So we get negative 64. Questions? Go ahead and try this next example. Okay, so we're going to use that formula again. So I begin with a sub n equals a sub 1 means first term, which is 32, plus n times 15. We're adding 15 term to term. We'll distribute that 15 in. And combine like terms to give us a rule of 17 plus 15n. If you wrote 15n plus 17, that's fine. It doesn't matter which way those go in the rule. I don't even have a preference. Doesn't matter. Then we are asked for a sub 12, which is the 12th term, or what we get when we plug 12 into the rule. So we plug a 12 into the n spot. And 17 minus 15 times 12 is negative 163. Sorry, plus. Let me try that again. It's not plus 163 either. There we go, 197. Sorry, bad copy error there. Questions? Our next question is similar, except we're not given the beginning of the sequence, so we're not given our first term, we're just given some term in the sequence. So we're going to use the same formula, but we have a little bit of a problem in that we don't know what a sub 1 is. By giving us any particular term, we are given an a sub n value, and we are given an n value. So that actually gives us two pieces of information to plug in along with our common difference, and we can solve for our a sub 1 value. So a sub n, some term is 30. We don't know what a sub 1 is. Plus n is 13, because that's the place in line of that 30 that we plugged in. It's the 13th term in line. Minus 1, and the difference is 3/2 or 1.5. So 13 minus 1 is 12, times 1.5 is 18. We'll subtract that 18 from both sides and find that our first term is 12. But the directions didn't ask just for the first term, it asked for the rule. So now this problem becomes like the last one because we know our first term and we know our difference. So we can plug that in and find our rule like we did in the last problem. A sub 1, which is 12, plus n minus 1 times d, which is 3/2. Distribute that in. And 12 minus 3/2 is 10.5 plus 3/2 n, or 1.5 n. To use given term as our a sub n value and use its subscript as the n to find our first term. And then we continue like the first type of problem. Questions? Try the next one, please. Okay, so we're going to begin with that same rule, plugging in 50 as our term value. We don't know our first term value, and 50 is the 8th term in line, so n will be 8, and that common difference is 0.25. So multiplying 7 times 0.25 gives 1.75, and subtracting that out gives 48.25 as our first term. Then we take that information and the common difference and plug it back into the formula. So a sub n is first term, 48.25 plus n minus 1 times common difference is 0.25. Distribute. And combine like terms to get 48 plus 1/4 n. Questions? One more type of problem. And we have kind of the typical progress here, where that last problem had one more step than the previous one because we didn't know our first term. We're going to have one more step in the beginning of this problem because we are also not given our common difference. We're just given 2 terms in line, and they're not even 2 terms that are next to each other. So we need to start by finding our common difference. We are going to do that by finding the difference between the 2 term values. So 55 minus 10 is the difference in the term values, but since they're not right next to each other, we need to take into account how far apart are they. So one of them is the 6th term and one of them is the 21st term. So we need to figure out how far apart are those 2 terms. So we want to subtract the values and then divide by how far apart are they in line. So the difference in the terms is 45. They're 15 spaces away from each other in line, which means that if the difference is 45 spread out over 15 terms, each time we must have been adding 3. So what we need to figure out is what did we add each time to get from a 6th term of 10 to a 21st term of 55. So we subtract the values of the terms and then divide by how far apart are they in line, and that gives us the difference that was added each time. So now we know our difference, and we know 2 terms, so we can just pick whichever one we like better and do it like the last problem. I usually pick the one with smaller numbers because it keeps the arithmetic smaller, but it doesn't matter. Either one will work. And then we do this problem like the last one. So plugging in 10 equals a sub 1 we still don't know, plus 10 is the 6th term, so 6 minus 1 times d, the common difference is 3. So using that same formula we've been working through. So 5 times 3 is 15. Subtract out, so our first term is negative 5. And now use first term and difference to write our rule. -5 plus n minus 1 times 3. Distribute in. And combine like terms. Questions? Go ahead and try our last example. What we need to do is find the difference in the two terms that were given. So 110 minus 10. So those were spread apart 100 in value. But since they're not right next to each other, we need to say how far apart are they in line. So one of them is 30th and one of them is 5th. So they are 25 spaces away from each other in line, which means that each time we must have been adding 4. So we have a common difference of 4. Then we take that common difference and either one of the two values, I like smaller numbers, but it doesn't matter, and plug it into our formula. So the term is 10. We don't know the first term. The place in line is 5 minus 1 times the difference we just found is 4. That multiplication gives 16. Subtract that out gives us a starting term of -6. Then we take our starting term and, oops, there's no way to get it back. Okay. We'll take our starting term, which we just found was -6, and our difference, which we had found was 4, and write our rule. So a sub n is a sub 1 plus n minus 1 times d. Distribute in. And combine like terms. And you can always double check your final rule with the original starting points and make sure that it works out okay. So like, especially the point that I didn't use here. If I plug in 30, I would have 4 times 30 is 120 minus 10 is 110, and we can see that it does work out to give us the correct value. Your homework is from 11.2 tonight.